Hello everyone, my name is Pritam and welcome to another video of the C programming playlist. And in this video, we are going to discuss about pointers. In the previous video, I have given you the brief introduction to pointers, like not exactly brief, but yeah, a basic idea of pointer, what exactly pointer is and what exactly it does. And apart from that, we have discussed that what are the things we are going to discuss in this video, so that like you could have a better understanding of the roadmap also in the entire playlist, in the pointer lectures, what are the topics we are going to cover. Now in this video we are going to start with the pointer. Okay, so here for example, I'm giving you a basic example. Okay, and after that we will talk about one by one all the operators, what exactly we do. Okay, so for example, integer a. Okay, now if I write printf enter any number and then scanf percent d comma and percent of a. Okay, and now if I write integer asterisk p. Okay, and then if I write p equal to n percent of a, and then if I'm going to write print of percent d, and then percent p comma, don't worry, I will discuss comma p. Okay, so and also here, if I write enter percent store and okay, so this is the code. Okay, now what exactly pointers are? First of all, how would you declare it? Correct. So let me talk about that first. So we can declare pointers as integer, sorry, not integer, I would say data type, and then variable name. Okay, semicolon. This is the way normally we used to write the variables, right? But in terms of pointers, a asterisk will be coming up into the picture. So what exactly this asterisk means, what it indicates, that this variable is a type of pointer which points to this data type. Okay, let me give you an example, like integer asterisk p. So p is a pointer which is pointing to an integer. Now you would ask that what is the meaning of pointing to an integer? Okay, so here this kind of diagram will help you. For example, it is an integer a. Like in our code, if I say here, like it is integer a and we have taken the input, correct? So how actually it will happen, like enter a number and then scanf, it will be percent d, it is m percent a. You know what is m percent a? I already told you, right? Like it is the address of operator. Now what is address of operator? Okay, it will store the value in a particular address of the memory. Now the question comes that what is memory? Okay, so memory is nothing but some of the, like this kind of blocks. Okay, for example, if you have 8 GB of RAM, okay, then what will happen that like integer a, like will take 4 bytes of the from the entire memory. So it will start from 0, obviously. Like I should make some more here actually. Okay, so it will start from 0. Okay, and after that, like after many, it will start by 0. Then for example, I have taken 100 here, and then it will end up by this because you have 8 GB of RAM. So what will happen, that 8 GB, 8 into 1024, that means MB 1024, KB 1024, it will be byte. Okay, so up to 0 to this entire thing and then -1, that will be the theoretical one. Okay, so practically the diagram is something else, and we will talk about that diagram as well. Don't worry about that. When we will be talking about the global variable and local variable, I will let you know that what exactly things are. As of now, to understand the pointer, this is far enough needed actually. That's why I am discussing only this. Okay, so when we are declaring integer a, what it will do, that like it will store the and store this a into a memory location. We don't know what exactly it is. Okay, so that's why we are using this address of operator. It will give you the address, like whatever the address is, I do not want to know. Wherever you have stored this variable a, put the value which I am putting here as a %d, which is a decimal one, put that value in that location. Okay, so in this location it will be coming up like this, and each and every block, okay, it will have like each and every block of it, okay, actually it will have actually these 8 bits. Okay, this is 1 byte. Obviously integer will take 4 bytes in our operating system, and in system also it is 2 according to the NSI, but in real life scenario in our laptops it will take 4 bytes. Okay, and each of byte will take this one. And how it will be implemented, it will be implemented like this. If you can see this diagram, so if I am inserting 20 here, so it will be stored like this. Okay, so first byte this one, second byte this green blue one, third byte is the green one, and fourth byte is the orange one. Okay, so here 1011000, okay, and after that each and every bits will be 0 only except this. Okay, this is how actually it stores. Correct. Now what will happen that, like, obviously, and then we are going to print %d is stored in the address and ampersand p. So now ampersand p, what it is, ampersand p is nothing but another actually format specification, okay, format specifiers actually, which will store the address. Okay, we can print the %d as well, but the warning will be coming up. I will show you. Okay, don't worry. And in the memory, and then what we are doing here is integer asterisk p. Now what this is the declaration of the pointer. Okay, declaration of the pointer, and we are declaring that this is a p is a pointer which will point to an integer. Why integer is needed? Because we have taken an integer a, right? So if we are pointing to this one, then we need a pointer which will point to a. As C is a statically typing programming language, we have to declare the type of the variable where the pointer will be pointing to. Okay, when we are talking about void pointers, that is a separate thing. One issue is there in this statically typing thing, and that's why the void pointer concept has come. We will talk about it later on, but as of now you understand that if I need a pointer which will be pointing to a variable which is integer, we have to write like this. Okay, declaration of pointer to an integer. Correct. Now what we are doing, that pointer, what pointer actually does, pointer actually stores the address of that variable. Pointing to a variable, which it means that it stores the address actually. Correct, it stores the address. Okay, and that's why it is like this. Okay, so it stores the address, that's it, nothing else. Okay, whenever it stores the address, we can directly go to that address and we can print the value. Okay, how we do that, we will talk about it later on in depth, don't worry. First of all, let me show you. Okay, see, 123, if I give the input 123 stored in the address of this in the memory, and you can see I have printed this line. I will explain, don't worry. I will printed this line and it gives the same value. So without touching a, we are printing the same value here using the pointer. Okay, now let me explain how these things occurs. So let me explain this in this diagram here. Okay, a is an integer. It will have 4 bytes, obviously, like this. So we are storing 13 for example here, and it's a pointer p which will be pointing to a. Correct. Now it's good. So address is, as we have seen, that address is coming in like this kind of things. Okay, so one address I have put here, and this is the address will be storing here also, because p equal to ampersand of a. So inside the p variable, the ampersand of a, that means the address of a will be coming and storing here. Correct. Now if you see that this p, okay, so now how the things will happen, what exactly pointer does, like now when you will be printing, like if you want to print the value of the variable, then you have to use asterisk p, and p means the address of this, because ampersand of a is like that, just like that. Okay, it's a variable which is storing the address, that's it. When you will be trying to print, the address will get the printed out, that's it. Okay, and when you will be using asterisk, which is a dereferencing operator, okay, or I would say, and actually this ampersand is actually called as a reference operator. Okay, and this asterisk is called as dereferencing dereference operator, I would say. Okay, dereference operator. Okay, and Yeah. So that is the thing. So now let me explain that how actually it will work. Okay. So here you can see that asterisk p equal to what. Asterisk p means asterisk of m% of a, because p equal to m% of a. And we can consider, just for remembering purpose, we can say that this dereferencing operator and referencing operator will cancel out itself, and we will get the a. What actually happens, like we can think of in another way also. We have the p, correct, we have the value. हम लोगों को किसी का एड्रेस मिल गया तो क्या करेंगे, घर के बाहर जाके वी विल स्टैंड आउट, खड़े रहेंगे. उसके बाद हम लोगों को अगर अंदर जाने का परमिशन मिल गया, ठीक है, हम लोगों को पास की मिल गया एक एस्टेरिक फॉर्म में, तो हम लोग क्या कर सकते हैं, हम लोग अंदर भी जा सकते हैं, एंड वी कैन गेट द वैल्यू. दैट्स इट. दैट्स अ सिंपल वे आई कैन एक्सप्लेन. आई थिंक दैट विल बी, that is the simplest one which I have read or found out or discovered, that this is the way you can remember actually what exactly asterisk and what without asterisk what it will happen. Okay. So if you have any doubt, I think you should watch this part again, I would say, and to understand. Okay, so here I would say this is the code, so where we are imprinting the value using asterisk p, and this percent p actually is giving the address. Now if you ask me, like, why can't I use percent d here? Okay, you can use, but a warning will be coming up that format specifies type int, but the argument has a type of integer asterisk. That means you are trying to print the address, but you are using an integer variable, integer small format specifier. Okay, but still the program will be executed, and if I give the input, you would see some digits are coming. Digit will be coming up, but this is not recommended. That's why I used p here. Okay, so you also need to use p. Actually, you should use p so that people could understand the format properly. See, this is the way it could be done. So this is the basic pointer and dereferencing and reference operator which I have told you about. Okay, now more on. Okay, now as of now, okay, so few more things like we can talk about. Okay, so for example, if I write here, okay, that for example, what should I do? Okay, so there are some m% of j, for example, and for example m% of 289, for example, and m% of, for example, I plus k, for example, m% of r here, which is register variable. Okay, so these are the four scenarios. Okay, now this will be valid, this will be valid enough. Okay, this will be valid because why? Because it's a variable, it could have an address, but a constant, cannot have an address properly, because it doesn't stored in a variable, right? So this operation is invalid. Why I am telling all these things? Because this kind of MCQs might be coming, so that's why. Okay, again, if I say this one, again it is not possible because it's a calculated value, and one constant will be the output, so it is not possible. And here what will be the issue? It is a r variable. R variable means it's a registry variable. Registry variable, we will talk about it, don't worry. And if it is a registry variable, then we cannot actually expose the address of it. So that's why these are the valid and invalid scenarios. Okay, please keep this in mind, because this will be necessary when you will be talking about this kind of operations. Many MCQs or Viva questions might be coming in your interviews or gate exams or college exams, so keep that in mind. It's a short note. Okay, anything left? Nothing as of now. Okay, we can continue. Okay, yeah, so another thing which I wanted to talk about is this one. Okay, so for example, there is a scenario where you have like integer a is there, and p is pointing to a, and another pointer h is also pointing to a. Okay, so let me code and you will be understanding what exactly I am talking about. Okay, so we can write if you want to write, like for example, here I have written integer asterisk p, then p equal to m% a, and both the lines you can combine and you can write like this: integer asterisk p equal to m% a. Okay, so yeah, so now you can see what is the thing. Now if you see the diagram here, okay, let me put it as q. Okay, so p is pointing to a. Okay, and Q is also pointing to A. Okay, so Q is also pointing to A. It will have both the addresses, obviously 100 and 100. 1 second, sorry, 100. Okay, here also it is 100, correct? So it will have the value 13, but the address is 100. We are considering as of now to like to not to make things more complicated, I am putting here in 100 only. Okay, so now what will happen that like it is also pointing to here, it is also pointing to here, as we have seen already in the previous video, in the previous program, that without touching the variable we can print the things. Here in the same way we can write printf a equal to %d backslash n a equal to %d, okay, comma asterisk p comma asterisk q as well. Okay, and if you see like here, okay, backslash n. Okay, let me run this. Okay, what is wrong, what is wrong, what is wrong? Oh, sorry. It will be printf. I'm pretty sorry. Python लिखते ना पूरा C printf. Sorry. Yeah. So here you can see a equal to 13. A equal to 13 has been printed out. So using P and Q. Now the question comes that if I want to change the value, how would you change it? A equal to a. Okay, a plus equal to 10 if I write, and if I do the same operation, then what will happen? You can see 23 has been printed out. Now if I write, for example, asterisk p equal to 34, okay, and then again if we do the thing, what will happen? You can see 34 has been printed out, correct? Now if I want to do the same thing, okay, with Q as well, like for example Q, and if I am writing 784 for example, and then if you write, so see 784, so using P, using Q, using A, each and every one is able to make the changes of the entire value where it is in 13. So that is how the thing is. Like you can consider these things you have the access, like you can think of like that, you have the access, another person also have the access of the room and they can put anything there. So that is how we can do it. Okay, and that is the beauty of pointer, that from one side if you change it, from another side also you can change it. So a centralized system you can understand, like where from anywhere you can change the values. Okay, from anywhere you can change the values, and that is the beauty of pointers. Actually, we will talk about it later on also in call by reference and many other stuffs, where you will see such good things, like about very interesting things about pointer. Okay, so this much for today guys, and I would say, like if you really like the content, then let me know in the comment section, and also and like subscribe the channel if you haven't subscribed yet, and please share this videos with your friends, because this takes a lot of efforts to create such content for you guys, and I am really loving to while creating the content for all of you guys. So please give me some motivation too. This is the duty of you as an audience also. So yeah, thank you so much, and see you in the next video.